Hello, I'm Mr. Akash Bodke from Department of Instrumentation and Technology Engineering. Today I'm representing my engineering physics project, Optical Fiber and Communication System, along with my friends Harsh, Jagota and Sanket Jori. Introduction. It is the method of transmitting information from one place to another by sending pulse through an optical fiber. It is used many multinational companies to transmit telephone signals such as BSNL. It is also used in internet communications. We usually use it in our day-to-day lives. The process of communication using optic fiber uses the following basic steps: creating the optical signal, involving the use of transmitter, relaying the signal along the fiber, ensuring that the signal does not become too distorted or weak, receiving the optical signal, converting it into an electrical signal. Communication system contains information source, electrical source, optical fiber cable, optical detector, electrical receiver, destination. So let's begin with block diagram. Here it represents how the information source is transported and it is output at last, and information is in original form at last. So let's begin with information source. As we know, a communication system serves to communicate a message or information. This information originates in the information source. In general, there can be various messages in the form of words, group of words, code, symbols, sound signal, etc. However, out of these messages, only the desired message is selected and communicated. Therefore, we can say that the function of information source is to produce a required message which has to be transmitted. Input transducer. A transducer is a device which converts one form of energy into another. The message from the information source may or may not be electrical in nature. In case, when the message produced by an information source is not electrical in nature, an input transducer is used to convert it into a time-varying electrical signal. For example, in case of radio broadcasting, a microphone converts the information or message which is in the form of sound waves into corresponding electrical signals. Transmitter. The function of transmitter is to process the electrical signal from different aspects. For example, in radio broadcasting, the electrical signal obtained from sound signal is processed to restrict its range of audio frequencies. Up to 5 kHz is in amplitude modulation radio broadcast and is often amplified. In wire telephony, no real processing is needed. However, in long distance radio communication, signal amplification is necessary before modulation. Modulation is the main function of the transmitter. In modulation, the message signal is superimposed upon the high frequency carrier signal. In short, we can say that inside the transmitter, signal processing such as restrictions of range of audio frequencies, amplification and modulation of signal are achieved. All these processings of the messages signal are done just to ease the transmission of the signal through the channel and the noise. The term channel means the medium through which the message travels from the transmitter to the receiver. In other words, we can say that the function of the channel is to provide a physical connection between the transmitter and the receiver. There are two types of channel, namely point-to-point channel and broadcast channel. Example of point-to-point channel is wire lines, microwave links and optical fibers. Wire lines operate by guided electromagnetic waves and they are used for local telephone transmission. In case of microwave links, the transmitted signal is radiated as an electromagnetic wave in free space. Microwave links are used in long distance telephone transmission. An optical fiber is low loss, well controlled guided optical medium. Optical fibers are used in optical communications. Although these three channels operate differently, they all provide a physical medium for the transmission of the signal from one point to the another point. Therefore, for these channels, the term point-to-point is used. On the other hand, the broadcast channel provides a capability where several receiving stations can reached simultaneously from a single transmitter. An example of broadcast channel is the satellite in the geostationary object of the Earth, which covers about one-third of the Earth's surface. During the process of transmission, the reception, the signal gets distorted due to the noise introduced in the system. Noise is an unwanted signal which tends to interfere with the required signal. Noise signal is always random in character. Noise may interfere with signal at any point in the communication system. However, the noise has the greatest effect on the signal in the channel. Receiver. The main function of the receiver is to reproduce the message signal in electrical form from the distorted received signal. This reproduction of the original signal is accomplished by a process known as the demodulation or detection. Demodulation is the reverse process of modulation carried out in transmitter. Destination. Destination is the final state which is used to convert an electrical message signal into its original form. For example, in radio broadcasting, the destination is loudspeaker, which works as the transducer, that is, convert the electrical signal in the form of sound signal.
Historic development. First developed in 1970s, fiber optic have revolutionized the telecommunication industry and have played a major role in the advent of information ages. Because of its advantages over electrical transmission, optical fiber have largely replaced copper wire communications in core networks in the developed world. In 1950, Harlow Hopkins and Narendra Singh Kampania showed that rolled fiber glass allowed light to be transmitted. Zhu Nazwan, a Japanese scientist at Tohoku University, proposed the use of optical fibers for communications in 1963. Nazwan invented the pin diode and static induction transistor, both which contributes to development of optical fiber communications. In 1966, Charles K. Cow and George Hopkins at Standard Telecommunication Laboratory shows that the loss of 1000 decibels per kilometer exists in glass, compared to 5 to 10 decibels per kilometer in coaxial cable, were due to contaminants which could potentially be removed. Advantages of fiber optic transmission. Optical fiber have largely replaced copper wire communications in core networks in the developed world because of its advantages over electric transmission. Here are the main advantages of fiber optic transmission. First, extremely high bandwidth. No other cable-based data transmission medium offers the bandwidth that fiber does. The volume of data that fiber optic cable transmit per unit time is far greater than copper cable. Second, long distance. In fiber optic transmission, optical cable are capable of providing lower power loss, which enables signal can be transmitted a longer distance than copper cable. Third, resistance to electromagnetic interference. In practical cable development, it's inventable to meet environments like power, substances, heating, ventilating, and other industrial sources of interference. However, the fiber has very low rate of bit error as a result of fiber being so resistant to electromagnetic interference. Fiber optic transmission is virtually noise free. The fourth point is low security risk. The growth of fiber optic communication market is mainly driven by increasing awareness about the data security concurrence and use for alternating raw material. Data or signal are transmitted via light in fiber optic transmission. Therefore, there is no way to detect the data being transmitted by listening in to the electromagnetic energy like leaking through the cable, which ensures the absolute security of information. Fifth, small size. Fiber optic cable has a very small diameter. For instance, the cable diameter of a single OM3 multimode fiber is about 2 millimeter, which is smaller than the coaxial copper cable. Small size saves more spaces in fiber optic transmission. The sixth point is lightweight. Fiber optic cable are made of glass or plastic, and they are thinner than copper cable. This makes them lighter and easy to install. The last point in the seventh point is easy to accommodate. Increasing bandwidth with the use of fiber optic cable, new equipment can be added to existing cable infrastructure because optical cable can provide a vastly expanding capacity over the originally laid cable. And WDM, wavelength divisional multiplexing technology, include CWDM and DWDM, enable fiber cable the ability to accommodate more bandwidth. What are the disadvantages of fiber optics? So fiber optic transmission brings lot of convenience. Its disadvantages are also cannot be ignored. Usually, optical fiber cables are made up of glasses, which lends to they are more breakable than electric wire. In addition, glasses can affected by various chemicals, including hydrogen gas, a problem in underwater cables, making them more scarce, which develop underground. The first disadvantage of optic fiber are is difficult to install. It is not easy to splicely fiber optical cable, and if you bend them too much, they will break easily. And fiber cable is highly susceptible to becoming cut or damaged during installation and construction activity. All this make it difficult to install. Attenuation and dispersion. As transmission distance getting longer, light will be attenuated and dispersed, which requires extra optical components like EDFA to be added. The third point is cost is higher than copper cable. Despite the fact that fiber optic installation costs are dropping by as much 60% a year, installing fiber optic cable is still relatively higher than copper cable because copper cable installation does not need extra care like fiber or cable. However, optic fiber is still moving into a local loop, and through technology such as FTTX, fiber to home premises, etc., and PONS, passive optical network, enabling subscriber and end user broadband access. Special equipment is often required. To ensure the quality of fiber optic transmission, some special equipment is needed. For example, equipment such as OTDR, optical time domain reflector, is required and expensive. Specialized optical test equipment such as optical probe and power meter are needed at most fiber endpoints to properly provide testing of optical fiber. The applications of optical fiber communications. Fiber optical cable find many uses in wide variety of industry and application. Some uses of fiber optic cable include medical, used as a light guides, imaging tool, and also a laser for surgery. In defense, it is used as hydrophones for semi-thick wave, and sonar, as wiring in aircraft, submarine, and other vehicles, and also for field networking. Data storage, used for data transmission. Telecommunication, fiber is laid and used for transmitting and receiving purpose. In networking, used to connect user and servers in a variety of network settings and help increasing in speed and accuracy of data transmission. Industrial or commercial, used for imaging in hard to reach areas as wire where EMI is an issue, as sensor devices to uh, make temperature, pressure, and other measurement, and as a wiring in automobile and in the industrial setting. Broadcasting or CATV broadcasting or cable companies are using fiber optic cables for wiring CATV, HDTVs, internet, videos on demand, and other applications. Fiber optic cables are used for lighting and imaging and as a sensor to measure and monitor a vast array of variables. Fiber optic cables are also used in research and development and testing across all the above mentioned industries. The fiber optic, the optical fiber have many applications. Some of them are as follows: used in telephonic system, used in some submarines cable network, used in data link for computer network CATV system, used in CCTV surveillance camera, used for connecting fire officers, police, and other emergency services. Used in hospital, school, and traffic management system. They have many industrial uses and also used for in heavy duty construction. Thank you.